With this architecture, with a 2.8 millions of lines of code, they easily handled more than 30 terabytes of traffic per minute during their Black Friday sales. Around 5 lakh commits are there, and they have currently 37 components in our main monolith. Hey everyone, welcome back to the channel. In today's digital age, platforms like Shopify, they've definitely transformed the e-commerce space, like how people use e-commerce platforms. But the architectural discussions that defines the architectural significance that they've adopted in building a huge 2.8 million lines of code base in a single monolithic architecture, that's quite impressive to understand. So in today's video, we're going to discuss the Shopify journey from a traditional monolithic architecture to a more modular monolithic approach, and how did they transition during this phase, and how are they able to manage this huge amount of code base in a efficient way. So as usual, initially Shopify started with a monolithic architecture. So classic monolithic architecture using Ruby on Rails. They use Ruby on Rails for that. So they started with Ruby on Rails with a classic monolithic architecture, and this monolithic architecture had all the functionalities. And in the monolithic architecture, they had all the functionalities that are required in a single code base like this. But initially it worked well, but as they grew, and the number of user base grew, and a lot of users started using the application, the single integrated monolithic architecture became very tedious to handle for them, the code base and managing the features and deployments, etc. So the developers also fell into a lot of trouble while managing the increased code complexity, then maintaining the code, and how to ensuring scalability, all those problems they landed into. So what they did to address this challenge, ideally what many organizations do is to go for a microservices based architecture. So there is a difference between a modular monolith and microservices based architecture. So in microservices based architecture, I mean, in a way it helps in scalability and isolated deployments, it helps in that definitely. But in a microservices architecture, basically we design independent parts of the application independently, and then deploy them differently on different machines or different servers maybe. Each deployment is independent of each other, and each microservice is independent of each other basically. But microservices based architecture comes with some complexity also. Like if you have two modules running into different machines, network calls has to be done between that, right? In order to, let's say there is a order microservice and there is a payment microservice. So the order microservice has to send some request to the payment microservice. So there is a network overhead definitely. And then there is infrastructure cost also. Multiple cloud machines or VMs to host and to run your microservices. So these are the main two complexity that comes with the microservices based architecture, like increased cost and network overhead. But Shopify did something interesting, and a hybrid approach of monolithic and microservice. Okay, what they actually did, they did not completely focus on the single monolithic architecture. What they did, they tried to build something in between. So they came up with a modular monolithic architecture. What do you mean by modular monolithic architecture? So think of modular monolith as, let's say, independent modules, sub modules in a single code base. That means your code base will be single. Between that, you will have different folders for each kind of independent functionality. So what they did, they designed each module around a specific business domain. For example, if we have orders to process, so orders will be a separate module, payments will be a separate module, card service can be a separate module, address management or profile management or account management can be a separate module. With this architecture, modular monolithic architecture, they reap benefits of two things. One is cohesion, and the next one is coupling. So if I write it here, cohesion and coupling. Now, what do we mean by cohesion? So cohesion means, let's say, it's kind of grouping the functionality of a given business domain. Let's say we have orders module, right? So all the functionalities related to order, like let's say these are the functionality, these small boxes, like create order, update order, dispatch order, right? All those things will be bundled together into a single package, and that is known as cohesion. Basically grouping together the similar functionality of a given business domain or given module in a single component or a single module, that is known as cohesion. What do you mean by coupling? Coupling means how much is the dependency between two modules. Like obviously if you have multiple modules, each module cannot run independently, there will be dependencies across, right? So the dependency, the level of dependency defines the coupling, right? So coupling you can think of is a measure of how one module is dependent on each other. For example, orders is dependent on payments, right? So you can say that orders is coupled with payments module. When playing with this modular monolithic architecture, they had to ensure that the dependencies is as less as possible, as minimal as possible. And in order to interact one module with another, what they did, they created a public interface in each of the module. Okay, through each module can communicate or talk to another modules in the application or in the code base. So that's how they first came up with this modular monolithic based architecture, which gave them the benefits of cohesion and coupling. Basically the benefit was of cohesion, and they tried to minimize coupling as less as possible. In order to minimize coupling, what they did, let's say that the dependency increased between two modules, right? Let me just take two more modules. Cool. So let's say this is another module. Let's say this is some XYZ module, and this is, let's say, some ABC module. Or let's say this is your address management module, and this is, let's say, personal profile, right? Profile management module. So if you see, both of them are basically dealing with the user details, right? User related information. So as the dependencies grew, I mean, if the dependencies grows between two modules beyond a certain point, what they did, they merged both the modules together and built a single module to handle all these cases or to handle all these functionalities. So that's how they reduced coupling as less as possible and improve cohesion. So because this is modular monolithic, that means entire code base lies, all the modules lies in a single code base. So the entire code base was deployed as a single process in a single server. And also it helped them reduce cost also, because they did not need to maintain multiple machines to deploy multiple microservices. The next interesting part is, in order to handle this, they had a well-defined folder structure. They organized the code in such a way that each modules contained a specific code logic, right? For example, if I just draw something here, let's say this is one folder. All right, let's say this is your orders folder. Similarly, we could have payments folder, right? And inside each folder, there will be separate subfolders. Let me just draw a subfolder for you. And this could be, let's say, this can contain its own models. Then similarly, another folder could contain its own views, right? And another submodule, or another folder can contain its own controllers, right? This is plain MVC example I'm giving, but there are other design patterns which you can follow also. Similarly, the same all three folders will be present in in your payment section also. All right. So that's how they organize their code into different modules. So each module is a box basically, and independent functionalities are organized in a separate module like this. And not only the folder structure, they also use separate databases and schemas for each module separately. And this way they avoided tight coupling between components, and they achieved cohesion and data isolation to a certain point. Now, what is the benefit of adopting a modular monolithic architecture? So the benefit that Shopify got is, basically, it is easier to modify code, right? Let's say if you have some feature or some bug to fix in the orders module, so you could go simply inside this folder, okay, fix the code, and you can have its own test cases, right? That's a very interesting thing also. Let's say you have an independent test folder for this, right? Where you write its own test cases there, okay? And if you fix something, let's say there was an issue in this functionality, you fixed it, then you can run the test cases on this particular submodule and ship that feature into production without affecting the other modules in the application. So this way, I mean, the code management became easier because the area of change was limited, right? I mean, the area where you are playing is very small here, right? Imagine all the code bases being in a single folder, that would have been complex. So, but because they decoupled it using a modular architecture, it helped them to see features and fix bugs faster than ever. So in this way, the developer productivity also increased because the code base was easier to understand, and you can actually they could easily assign separate developers to separate modules independently without worrying about the other modules. Because there is no network overhead, they simply use the function calls because all of them are on the same machine, right? They run on the same machine as a separate functions only. So each module could call the functions in another module directly by inputting that module, and that was enough, right? As you told, the infrastructure costs are definitely low because the entire code base is running as a single process on a single machine. But it's not like this is the godlike architecture. Okay, even if this works for Shopify, but still it has some trade-offs to deal with. For example, if you want to scale a particular module, let's say you want to scale your orders module where you are getting a lot of orders, right, frequently, you might want to have more resources for your orders module and payments module, but that is not possible in this case. In order to have that, you need to expand increase the resource capacity of all the other modules, because the entire application runs a single process. That means the resources will be used for cards also, everything. So which might be unnecessary, and there might be resource wastage also, because every module is running in the same machine or as the same process. If something fails, all the process in the application might fail. So those are the few trade-offs that you need to take care of, and if you are okay with that, compared to the trade-offs in microservice-based architecture, you can definitely follow this. Modular monolithic can be a great design pattern to follow and write and design your application code base like this. With this architecture, with a 2.8 millions lines of code in the modular monolithic architecture code base, they easily handle 30 TB, around 30 TB, more than 30 TB terabytes of traffic per minute during their Black Friday sales. Around 5 lakh commits are there, and if you just search for this, they have currently 37 components in our main monolith. That means 37 modules or submodules like this they have in their code base. And each component or each submodule has its own public endpoint where it can be used to talk to other modules. So if you, I'll suggest you, I'll put the link of this blog in the description section. You can go through it. It's quite interesting, and they've discussed a lot of other things also, how they attempted to remove the cyclic dependency between modules, right? And how did they balance loose coupling with high cohesion, which you already discussed, but they've explained in a detailed manner here. So I'll put the link of this article in the description. Please go ahead and check it out. Okay, you'll definitely find it interesting, and you will get to learn a lot of things in a system design perspective. That's about today's video. If you like this video, hit a like. Let's target for 50 likes for this video, and subscribe to my channel. We are targeting to reach 3,000 subscribers by the end of this month, so keep supporting. So I create this kind of in-depth tech videos in my channel. You can go ahead and check out my Learn Out of the Box playlist, and you'll find a lot of use cases like this, and you'll definitely love them. Please check them out. So thank you for watching this video, and if you have any questions around the discussions, please drop a comment. I'll answer them. Thank you for watching this video, and I'll see you in the next one. Thank you.